This video is going to be about ion exchange resin, so removing the hardness from water. Okay, so we should know at this stage that hardness in water is caused by Ca2+ and Mg2+ ions. Okay, so they are what cause hardness in water. And that's what we want to remove. Okay, if we want to remove the hardness, we need to remove those ions. They're positively charged ions, so they can be referred to as cations. Negatively charged atoms would be referred to as anions. There are a few ways of removing these ions from water. There are 3 that are looked at in your course. The first one would be distillation. The second would be by using washing soda. And the third one, the one that we're going to look at here, is using ion exchange resin. So in simple terms, what ion exchange does is it basically swaps the anions that you don't want, so it swaps the Ca2+ or the Mg2+ out for ions that don't cause hardness in water. The most common one that is used is sodium. Okay, the charge on sodium is just Na+. So in order for those sodiums to replace the calcium and the magnesium, you have to exchange 1 calcium for 2 Nas. So you'd have calcium Ca2+. If you remove the calcium 2+, you will then have 2 Na+. That is just to balance your charges. Okay, so you still need an overall charge of. Okay, so that ion exchange resin that we talk about, the chemical formula for it is quite complicated, but we just represent it as Or and then Na for the sodium that we are concentrating on in this. When we look at organic chemistry, you'll see that Or is used as a letter for a side chain or something else joined on to the atom or molecule that we are looking at. So if we look at our formula, for our hard water, we're just going to look at the ions that we're interested in. So in this case, we're going to go with calcium. So we look at Ca2+ plus 2 or Na. Oops. And when they we'll call react together, you have Or 2Ca plus 2Na plus. Okay, so here again you'll see that there's 1 calcium for every 2 Nas. So here. And again then at this side, so this is your ion exchange resin. This is representing your water. At the right hand side of the equation, this is now what's representing your water. It has sodium ions instead of calcium ions. And this is representing your resin that's left in your column. So if we look at having an actual column, not the best at drawing, but if you have a column like that, at the bottom of a beaker. Okay, and in here then you have your resin. Okay, so at the start this is full of Or and A, Okay, if you pour your water in, that's containing your calcium or magnesium ions, as it goes down through the resin, what happens is the calcium that is in the water, or the magnesium, we'll use calcium, right, is replaced by the sodium in the water, and what happens is these NAs move into the water, and then here you're left with your calcium, and then in your water at the bottom you are left over with your sodiums in your water instead of your calcium, and so you have removed the hardness of your water because you've removed the ions that are causing the hardness in the water. Of course, at this stage this resin now is no good to you because it has your calcium ions in there. So to replenish this resin so you can use it again, what we do is we just pass a solution of sodium chloride down through it, and again your sodiums will then replace the calciums, and again you'll have your ion exchange resin ready to go again. Now we may notice though that there are still ions left in this water, so this water that's left down here wouldn't be suitable for use in a lab, okay, because there's still ions in it, so it's not deionized water. So in that case, the resin that you would use would be slightly different. Okay, so in this case, we're not actually talking about moving hardness from water in this case, but we're talking about moving from a solution of water that has ions present to one that is deionized. So in this case, if we had water, for example, that had NaCl in it, if we add in water that has NaCl, we should know that Na is positively charged and chlorine is negatively charged. So we need something to remove these positive charges from the water, and we also need something to remove these negatively charged ions also. And what we use to replace the Na pluses is OH minus, and what we use to replace the Cl minus are H pluses. As that passes down through the resin that contains these two compounds in it, the ions that we don't want are replaced by the H plus and the OH minus. Now you might think that, well, you're replacing a positive with a negative and a negative with a positive, so you should still have what the problem you had at the start. What actually happens is, though, if we have here, we have H plus OH minus, well then they're going to form H2O. They're going to form water, which we want. Okay, so that is why it's a deionized solution, that we don't have ions left. Okay, because the H plus and the OH minus creates your water that you want. So in here at the beaker at the end, after your water has made its way down through, your Cl minuses have been replaced by the H pluses, and your Na pluses have been replaced by your OH minuses. Okay, so one ion is substituted for another as it passes down through the resin. At the end then you have H2O deionized water. So I hope that makes sense.